Hello friends, you are welcome again in our channel SKS Learn and my name is Sanjeev Kumar Sharma and today we are going to learn a case study that's a practical prospects of the K-means. Remember in our last video we have covered all the theoretical part of the K-mean. Today we are going to see our case studies in a Python and we will see how can we analyze the K-means on a case studies with a cricket data. And here we are going to analyze the Alvo, KeyLocator, Silhouette, DBScan, and ARI. The steps will remain same. You can see the steps content we will cover in this video. We will go to the imports of the library. We will do EDA. We will standardize our scales. We will find out the k-means, Alvo methods. We will check what is the locator of that. And there's another technique, Silhouette, and another techniques, DBScan and ARI. So today we will cover four techniques actually for K-means today. It's the Alvo, Silhouette, DBScan, and ARI, and we will check the accuracy of that all four. Which one is better? Which will give us accurate, you mean that cluster result. So let's see what is the scan. This is my checklist files which I have created for you, and let's go to the coding files. We will not spend so much time on the theoretical part. Here in the one tab I have covered some of the theoretical parts, so you can see it for your reference only. In the coding part we will go through today for the 9 steps. Let's see the what is our first step. It's a, of course it's an import, so we will import all the directories. If I talk about, it's very simple. We are importing lots of Panda, NumPy, Matplotlib, and C1. After that, we will read our files, and after that, we will do the basics like head, tail, describe, shape, and info. I'm sure after all, we are working on the Python, and this is very basic steps which we have covered in the first steps. Import. Now I will go to the second. That's the EDA, and we always do EDA in every type of the analysis in the Python. In the EDA, what we will do actually, we will do our cleanings, our duplicates, and we will check if the data is the right format or not. Let's see. In the k-means studies, we will split our columns. There are some columns which we don't know, or we have to do some calculation. If here I talk about this case especially, so in this case, if I go to import part, now you can see, right? There's an import part which we have done. We have imported our files. Okay, guys. One thing you are noticing here, that's after the importing the main files, I have used encoding Latin one. So what is that? Actually, my file format is a CSV, and that is a text to format. It's not column wise. It's just a dump of CSV file. If I will use that encoding Latin, this will convert that to a text to columns in the column wise and show me that columns. Otherwise, this will not import the files in the right format. Let's see format head. What I have a player's name, span, match, innings, not out, runs, they are heavy, average, BFAPs, SR, 100, 50, and 0. Okay, shape is 79 by 30. If I see how they describe, it's a very common which we can see. Info, I am not seeing any not null values here, so you can also check that. If I can check the row number 7, it's a null value 0. Good. Okay, from now here onward, my EDA starts. If I talk about the data format, I have a player, I have a span. You see span. Span means the timing, the duration when this player played out. If I talk about the first line, SR Tendulkar, Sachin Tendulkar, it's a 1989 to 2012. So in the first format, if you see my code, so what we have done just the text to column of this column 1989 and 2012, and we have created a new column to get the difference of this timing. So actually we can know how many years a player played. So that same thing we have done this other columns. See, to convert the span into years, we have split the columns, starts and end with the we have separated two columns, start and end, span by, and based on that hyperlink between two. And the third, uh, we have created new columns, experience, and the experience column is coming by the end period, end year minus the start years, and we have dropped down because we don't need that two extra columns which we have created to start and end years. So we got this set. Finally, we got the columns. Now we can create bar plot. Otherwise, I don't think we need that for key means. This is all your wish. You want to see the comic colorful visualization before between players' name and their runs, player names and their no balls, player names and their top 100, anything. So you can create the bar plot. Otherwise, this is not necessary for the key means. Okay, while creating bar plot, you will get some errors. Like I can show you. See, if you are seeing that Sachin Tendulkar's line is a HS, so you are seeing their star ahead of the 200. So when you will create a barcode, this will give you error because this is not a numerical part. So this, with the help of this simple code, extract, you can avoid that all the stars or dash, whatever the extra things is there, we can convert them in a integer. So now our plot will work. Now we have to check the outliers, and outliers we can check through two ways. Either we can plot the box plot, and you know, guys, we have already done this earlier, or you can create the Boolean charts. And there, I am just trying to give you the two ways of creating Boolean. First is this, a simple address SNS, and second is this AX by plot. Let me give you that live. Now I can see my describe, save, information, no null. So this is the same thing in the EDA. I have created two columns. I have dropped columns and the new columns is at the end I can see experience. Right, guys? So now I can see the 23 years of experience of the as a first line, second is 15 year experience. Now you can see all the columns name is here. I have created the bar plot between the players and their match played. The same way I can create the players with the no and no not out. So this is all my base. This is not necessary. In this code, I have removed that the extra things from the this 200. You are seeing that extra. So I removed that, and after that the bar plot is uh, decorated for the HS also, right? Now I can see that I have created the violin with the help of this SNS plot. You can do this for any columns, right? And I have created violin for the another way. It's the x dot violin plots, and I tried to create a three violins in the same graphs. You can see runs, HS and mat at the same times. There's another way. I have just created the AX1, AX2, AX3. I'm just giving the their you can see the uh, uh, you can see on the graph of the if I'm creating this graph, so I'm just giving them the columns wise. It's AX1, AX2. Here I have taken the eight columns in a row one and eight columns. See, you can n columns is eight, and on a eight columns I have given the runs, HS, NO, experience, match, innings, average, 100, whatever columns you want to show. And at the end you will see I have given one the so medians every line. So on each of the point you will see the medians lines here. Like for this runs middle line is below 125. For HS you can see middle line is above is almost between 20 and 30. Right? This is another way to create the volume and check the outliers. Okay, now what I am doing, now I am going to do, uh, we have covered this other way of the creating, drop the name columns. Because guys, we are just going to create the k-means clustering and we don't need anything which is names, right? We need only data which is numericals. So players names we don't need actually. So we can drop that column, players name, first columns, we adopt this. Second is done. Now third, we have to move from the EDA to standardization scale. What is this standardization scale? I believe you have done this scaling part in a decision tree also, in a K-meals also, and you will do this in future also when you will cover your PCA, LDA, or other types of the analysis. Why we do this standardization of the scales? I tried to cover out the theoretical part same time if you have any doubt. So standardization scales or the shifts, the value of the each numerical features in your data set so that the features have a mean of 0. and standard deviation of 1. So we are just trying to create our mean at we are just trying to find out that point where our mean will be 0. So that will be center point for every data, right? Of course. Let's import that standard scalar. We import this from the sklearn pre-processing. We fit our model. It's a very simple, and we will create our columns. If you go to the code files, after removing the players column, because this is not numerical, so we don't need this. I can see the head columns. Now I cannot see anything which is not integer. I imported a standard scalar and I have fit my model. Now you can see everything. These are the points where uh, my mean is 0 here. From 0, these points are coming out array, and we have created multiple arrays at column by each. If you come to column wise, we can see you are seeing the code on a row number 25th, right? This is the same value which we are showing here. Here you are not able to understand this value because this is creating column wise array. But if you want to see this in a beautiful format, you can this use this code, scalar columns, and give their code name, column names. So now same value you will see like this. Format this experience, everything is there, right? So standard scalars we came to know what is this actually. Now let's move to the next k-mean. What is k-mean actually? We have already covered the theoretical part, but let's see. The k-mean clustering method is an unsupervised machine learning techniques. It's a used to identify the clusters of the data objects in a database. There are many different types of clustering method, but k-means is very one of the best, oldest, and easy to understand. I'm not saying that k-means is good or best because when you will go to the next, we will do the k-mean, we will do the Silhouette, we will do the DBScan, we will do ARI. Later on, we will come to know k-means is best or not. Let's move that. What is k-mean? Okay. For k-mean, let's import all the diaries. It's from the sklearn clusters. Import the k-means. Okay, I have imported my k-means. So you can see the k-means clusters here. Now I'm fitting my model to k-means. Okay, let's see. Now by fitting my model, I've given a range 2 or 8. You can give any range. That's all depends on the data types, whatever time to give, right? And its code is very simple. You are just doing the k means and the maximum integer taking the 150 and the random taking the 0. If you want to do what is the maximum interior, there are many questions. Let's see what is that. See, you can see in front of columns only. So some technical words you will come to know. N clusters. What is this N clusters here in code? It's a set K for the clustering steps. This is the most important parameter for the K maze. And you will see another technical word. It's the N slash init. What is that? It sets the number of the initializations to perform. This is important because two runs can coverage on a different cluster assignments. The default behavior of the script learn algorithm is to perform 10 k-means run and return the results of the one with the lowest SME. So by default, it's a 10 guys, right? Now I hope you can understand this formula easily. What is the mean of n cluster and what is the mean of ITR and what is the mean of random state? We all know, right? Now let's fix the model and plot the LO. What is LO? You can see this plot here, right? Easily. If I see this chart, what is this LO? This LO is giving me a chance to see the number of clusters, what is practically possible. But if we are following the k-means, so this is always advisable to go for a best fit point like this. You can see this point. Let me use the pen. This, where my curve is going creating a L, right? This one. So this L point, so here from my data is going to create a L and drastically going down. So this is always best to use this point as a cluster results. So from my data, the best cluster points are four. Four clusters can be created. Four clustering can be possible if I follow the K maze. Hopefully you got it right. Okay. Now let's move to next points. What is that? We have created K maze. What is DLocator? Do you know this, guys? I believe no. Let's see. That's the knee locator. Why we need that? You are having trouble choosing the elbow points to the curve. Then you could use the knee. It's identify the elbow point program utility, right? Because that is not practically possible. That okay, if I'm going giving you this chart for me, this point is best. For you, maybe this is best. For another guy, this is best. Another guy can three. This is the elbow point actually, right? Who is right? So to solve this issue, let's use algorithm, right? There's another method, the locator, and here we are doing the same. We are importing the locator, and sometimes you will face the issue to import, so you can use this pip install, right? I have highlighted there. So here, install the nil, right? If you don't have the systems, after that you can import this nil locator, and you have fit your values, model criteria, and you can see the interaction. What is the interaction? Sets of the numbers of the maximum interaction of the each initialization of the key main algorithm. Right? Let's see how the result. If I use that key locator, I have used that key locator, and now my result is three. As per my formula, that 3 point, this one should be my result, is the best because here I'm making a elbow. From this point onward, data is going down. So hopefully you guys know what is the benefit of nil locator now, right? Okay. After that, we will move to the next techniques. It's called very easy techniques, silhouette, right? There's another way, like we use the k-means. We simply imported k-means, find out the how many clusters, and that to solve the problems, we use that nil locator. So we got the answer three. Three clusters is best as per the k-means. Okay. What is silhouette? The silhouette coefficient is a measure of the cluster's cohesive and separation point. Now, here, what is that? Why we use that? Okay. So it quantify how well a data point fits into a assigned cluster based on two factors. Number one factor, how close the data point is to other point of the clusters. And second, how far away the data point is from the point of other clusters. So we always see the two conditions here. This actually count. This all done without the formula. You are not doing this manually, but we have to understand how this silhouette is working, right? So we have to analyze. This will analyze how close the data point is to other points of the cluster, and how far away the data point is from the points in other clusters. Slotted coefficient value range between -1 and 1. Larger number indicates that samples are closer to their clusters and then they are to yet another clusters. Hopefully you got this, right? Larger the numbers always indicates that samples are closer to their clusters, right? It's good. I mean, that is good simple. It's closer to clusters, and they are to other clusters. There are other clusters also, right? Its rules are simple, same. Let's import this lote from the SK learn matrix, define the model and fit your model. There are another theory we can cover this. What is the silhouette score? We are using this fit and model. Compute the mean silhouette coefficient of all the samples. The silhouette coefficient is calculated using the mean intra-cluster distance A and the mean nearest cluster distance B for each sample. This is another way to find the best k-mean cluster. Now you will see this. I will grab that. I will plot that also. At the end, we will plot the clusters. Now, after that, we will do the accuracy check. Once I will plot that, this will look like this. Alignment clusters and new columns. And after that, we will do the plot clusters plot, but not it's not necessary. You can see, and we will check the filtration. Let's see live now. Okay, the locator we have done. We got the answer. Okay, model cluster inter we have done the lowest SME. This is just a simple thing you can check yourself. What is the center point? What is the interior? Okay. Now we have to cover this silhouette, right? So I imported silhouette here from the sklearn matrix, and now I'm trying to fit my model. And as per the silhouette, you can see the scores are coming like 031212018. This is another way. I always prefer to like this way plot area. So let's fit my model in the plot. Maximum table will be same, remains same. 150 random instead you can gain many things. This is my cluster silhouette points you can see easily, right, guys? If you will analyze this also look like a same k-means, but the difference is only one clustering separated 0, 1, 2, and 3 maximum, right? You can see clustering labels here, guys. You will see the maximum 0, 1, 2, and 3. That means this is not going beyond this 3. So as for this also 3 clustering is best model, right? If I see about the clustering IDs in my data set, so they have also created the 4 clusterings. If clustering ID is 0, 1, 2, and 3. Hmm. See, it's not necessary. If you want, you can create this scatter point as per your choice. This is not necessary, right? Now this code is important. Now I'm trying to find out all the rows which is having the cluster ID 0. 0 means this is another cluster. This is one cluster which is all 0 club that. In the second row, I am trying to find out which cluster ID is 1. All the row lines. Row 60 is a cluster 1. 37 is cluster 1. 70 is cluster 1. This is a separate group. In this code, I'm trying to find out the cluster ID is 3 and same way the 2. So we have see all the data, all the rows which are aligned to call cluster 0, 1, 2, and 3. Right, guys? So this is called silhouette techniques, and uh, this is very easy. Just another way to like game is to see how many clusters best fit to the your model. Now let's move to next techniques. It's a DBScan. It's this is called advanced techniques, and what we'll do actually evaluating the customer performance using the advanced techniques. This is, the technique will remain same. We have to import our libraries from the sklearn cluster. We have to import the another library for make moves and the adjusted rand score. Why? What is that? Why we are uh, importing that? Okay. The ELBO method and the Celote coefficient evaluate clustering performance without the use of the ground truth labels. Ground truth labels categorize data points into groups based on assignment by a human or an existing algorithm. These types of metrics do their best to suggest the correct number of the clusters but can be deceiving when used without the context. So that is a drawback of the k-means and movement. That's why we are moving to this DBScan. This time, use make moon to generate synthetic data in the shape of the crescent. Right? That's a simple purpose of the make moon. And we will see when comparing k-means against a density-based approach on the non-spatial cluster. The result from the elbow method and the slow-take coefficient rarely match. And a human intuition. Human intuition means that's all depend at the same times. You can see the elbow method. You can see any point as per your choice or your understanding. And the same in the Celote method. Elbow points can be anything. That's depend on the human intentions. This scenario highlights why advanced clustering evaluation techniques is necessary. That's why we move to the DBScan. There is no human intention. Result will be accurate, right? Let's move. The process will remain same. Import, define the above models, k-means and db scans. Now we will see the difference. If we use k-means, if we use db scan, what will it score, right? So that's a separate. We I'm just trying to show here. It's available in advanced techniques. Theoretical part is so involved here. Okay, let's import all the diaries. Whatever I know here. It's a DB scan, make moves and adjusted and score. Fit the above model. And now see, I'm just trying to came in and DB scan algorithm fit model in the both and checking all the levels in the both side. If I try to do print this low-tech coefficient over each of the two algorithms and compare them, right? Now I'm just trying to say low-tech, right? If I use the k means low-tech, it this will coming on a point 0.5. If I'm using the DBScan slot, it's a 0.38. So you can see, guys, the difference, the lesser the difference, best the model. So you can see 0.38 is a less than the k-means. DBScan is best here, right? There is no human intention like you have to see the elbow point or you have to decide yourself. This is the best things you can do. If right, is the first you can see. So that's the same thing we are trying to understand which one is best and giving the right result with the minimum difference between the clusters and the more accurate and logical values. So if I see the k-means is zero point 0.5, DB is 38. Sloan the coefficient is higher for the k-means algorithm, right? The DB scan algorithm appears to be find more natural clusters according to shape of the data because it's just a 0.38 difference. I'm just trying to plot the graphs. So on the graphs also you can see how this will look like. The code will remain same. You can see that is this is very easy. K-means plot. Here I'm trying and I'm here trying to plot the DB scan. So the first one you can see cell voltage is zero point 0.5 for K-mean and for DB scan it's a 0.38 and you can see much better. And what you got? What is the difference here in graphs? No, let me tell you. These red part, right? Almost same, right? I'm not seeing any difference here. But some blue parts are mixing in the red, right? And here some red are mixing with blue. See? But if you do the DB scan, you will find a very accurate model. Red is one side and blue is one side. So which one is better? You decide. This one is better, right? And at the last there is another technique, guys, that is called ARI, Adjusted Rand Index Method. This is another method just like a DB scan and advanced level. Since the ground truth labels are none, it's impossible to use a clustering method that considered labels in its evaluation. You can use the scikit-learn implementation of the common matrix called the adjusted rank index. Unlike the Slote coefficient or the ARI, use the truth cluster alignment of the measure the similarity between the true and predicted labels. It's very simple. We will plot the graphs and we will see that what is better. It's a k-means or DB scan, and we will plot the ARI of that k-means, ARI of that DB scan. So if I see as per the ARI of the k-means, it's a 0.47. As per the DB scan, it's 1.